Okay, so we're going to continue today's lesson about volume. We looked at problem number 9a. We looked at doubling. What were we doubling? We were doubling the height of the cone from number 8b. Now we're going to double the height of the cone from number 8a. So number 8a had a cone with a height of 5 units and a slant height of 13 units. Recall from a previous video lecture that the base radius was 12 units. We're doubling the height, so the new height is 10 units. To find the volume of a cone, we use the formula 1/3 area of the base times the height. And so since the base is a circle, we have 1/3 pi r squared times the height. The radius is 12 units and the height, the height is 10 units. So we get 1/3 times 144 pi square units times 10 units. And that gives us 480 pi cubic units, or approximately 1,507.96 cubic units. Okay, now we're going to take a look at problem number 9b, where we have the radius that gets doubled and the height remains the same. We want to find out what happens to the volume. So we'll start with part B. This is the cone that has a height of 2 units and a base radius of 1.5 units. We double the radius, so the new radius is 3 units, and the height stays the same at 2 units. And we get the volume using the formula 1/3 area of the base times the height. So we have 1/3 pi r squared times the height. Plugging in 3 units for the radius and 2 units for the height, we get 1/3 times 9 pi square units times 2 units. This gives me 6 pi cubic units, or approximately 18.85 cubic units. Next, we will look at the cone in part A. This was a cone that had a height of 5 units and a slant height of 13 units. We've already found that the base radius was 12 units. We'll double the radius, so the new radius is 24 units. Again, we use the formula that the volume is 1/3 times the area of the base times the height. The area of the base is pi r squared, and we know that the radius is 24 units and the height is 5 units. So we got 1/3 times 576 pi square units times 5 units, and that gives me 960 pi cubic units, or approximately 3,015.9 cubic units. Next, we'll compare the answers and we'll see what happens when we double the height versus what happens when we double the radius. So let's take a look at the cone from problem number 8. Part A, we had the height was 5 units and the radius was 12 units. We found that the volume was 240 pi. If we double the height but leave the radius alone, we find the volume is 480 pi, and the volume was doubled. If we look at the cone from part B, the original cone had a volume of 1.5 pi units. If we doubled the height, we found that the new volume was 3 pi cubic units, and so again the volume was doubled. If instead of doubling the height, we doubled the radius, for the first cone, we got the volume, the new volume was 960 pi. So the volume was multiplied by 4 from the original volume. The volume quadrupled. And if we look at the cone from part B and we double the radius, the new radius is now 3 and the new volume is 6 pi. Again, the original volume was multiplied by 4, so the volume was quadrupled. Next, we'll take a look at problem number 11. Problem number 11 says racket balls are typically sold in cylindrical cans containing 2 balls. If a racket ball has a diameter of 2.25 inches and the 2 balls fit exactly into the can so that they touch the sides, the top, and the bottom of the can, how much space in the can is not occupied by the balls? So here's a rough drawing of the situation. We have the 2 balls inside the cylinder. To find the volume of the air, we'll find the volume of the cylinder and subtract the volume of the 2 balls. To find the volume of the cylinder, we multiply the area of the base times the height. The base is a circle, so its area is pi r squared. Since the diameter of the balls is 2.25 inches, the radius is 1.125 inches. And since the cylinder holds exactly 2 balls, each with a diameter of 2.25 inches, the height of the cylinder is 4.5 inches. So the volume of the cylinder, again, we're using pi r squared times the height. We get pi times 1.125 inches squared times 4.5 inches. This works out to be 5.693125 pi cubic inches. Next, we'll find the volume of the 2 balls, and then we'll subtract that from the volume of the cylinder to find the volume of the air. The volume of a sphere is 4/3 r cubed, and the radius we know is 1.125 inches. So the volume of each ball is 4/3 times pi times 1.125 inches cubed. And this gives us 1.898 roughly. To find the volume of 2 balls, we'll just multiply that number by 2, which gives me 3.796875 pi cubic inches. And to find the volume of the air, we subtract, we take the volume of the cylinder minus the volume of the 2 balls. Okay, and that, again, we take the volume of the cylinder, about 5.69 pi cubic inches, and we subtract the volume of the 2 balls, 3.797 roughly pi cubic inches. This gives us 1.89625 pi cubic inches, or approximately 5.957 cubic inches. Okay, so that is our lesson for today on finding the volume we worked with cylinders, spheres, and cones today. Please feel free to send me an email if you have any questions or if there are certain problems that you'd like to take a look at. I hope everyone's doing well. And please let me know if you want to join one of my sessions, and I'll try to help you out as best I can. Thank you very much, and have a good day.